Today we will learn how to blow down a boiler gauge glass. This, what we have is a composite boiler whose gauge glass is right here. Here you see the gauge glass is there on top, there are one connection, and the bottom there is one connection. Here you see on the top the connection, this is the steam inlet connection side, and on the bottom side there is a water inlet connection side. And to join the both steam and the water side, there is a bridge which we call as a gauge glass. This is further divided into many sections. Let me show you more closely. We'll bring the camera a little bit closer. This right here is an NWN, which is a normal water level, which is marked, and the readings are also marked as +5 up to +5 +10 up to +45, which means up to +450 mm, and the same way it goes down also. NWL, normal water level, and from there these are marked as low water level at -41, which means -410 mm of water level from the normal water level. This right here, what we have is a black color. Yeah, this one is a DP cell for the water level controller. Let's learn how to find out the current water level. Let's see what is the current level in the gauge glass. I will try to bring the camera a little bit closer. It is almost near to +6 right now. Yes, this is the water level. This one near to +6. Yes, okay, now I think we can see the current water level is +6. Okay, so the gauge glass can also be operated both locally and both remotely. We will see that also. For the remote operations, yes, these are the wire slings, metal wire slings connected with the bulldog rig going across the easing gears and another easing gear, and it goes down below. Yes, this is the handle from which we can remotely operate the levers of the steam and the water side, or we can operate remotely from these gauge glasses in case if they are leaking. Just for safety protection, these are given if you do not have the access to come to the local position. This one on the top is the steam handle, and the bottom side there is the water side handle. Also, blue color valve is also a drain valve. The position for the safety purpose is vertically down in a closed position. So when I push the handle down, you see nothing is there in the glass. Now I'll try to push it down. It has to be done with a little bit of force. See, now if I push down, you will see nothing is there in the glass. Now I am trying to slowly open the drain valve, which will drain all the water from the gauge glass to the drain pot. I'm trying to show you that the thing is there. Once I open, you see while I'm opening, the position of the drain valve is coming little bit upwards. It has to be at an angle of 90 degree horizontally. That is for the safety purpose, so that by mistake we do not open the drain, because the water inside is also very hot and it also has a steam inside the gauge glasses. You see a green color something which is a gasket on the both end of the gauge glass. We will discuss and learn this in a bit. Now I will try to again shut down the drain valve by bringing the position of the valve vertically down, and I am trying to open both the inlet of the water side first and then the steam inlet side secondly. This is to ensure, because of the steam, the gasket does not break, or just in case the steam does not leaks and it harms you also. Always try to open the water side first. Once the water comes up, then you slowly open the steam side first. And now you see the level is somewhere around after blowing down it is coming. Yes, now you see once the steam comes, the level of the water slowly goes down, and then eventually it will come to the exact level what is there. It is somewhere around +5 right now. Yeah, so you see it is properly sealed, the markings are there. These are the gasket which I discussed earlier also. These gaskets every marine engineer knows, we know, just to seal the surface area. It is given on the both hand side. So this is a high temperature gasket also. Always I recommend to use the maker gasket instead of making from the GP gasket sheet. So you see there are the connections to inlet valve. These are the drain valve. This valve is a vent valve which is there in case if you want to drain and empty the boiler for inspection. This is the DP cell for the water level controller. Now we will go down to see the burner also. This right here, 2 pumps you see, these are the pilot ignition pumps, and the boiler is giving ignition right now. You can see the flame from the both ends. Yeah, this one is right here, the kind of FD fan for the combustion. These 2 are the photo cells which are given to ensure that the flame is there. They will give alarm in case the flame failure is there. So you see combustion is happening quite nicely. You can see the flame burning red hot. Fuel oil lines. This is the manhole door when we are doing cleaning or inspection. This is the burner control panel. All the parameter alarms, the controls, the drum water level controller, it is showing. So it will always keep on fluctuating because the pumps are always running and they are trying to cope up with the level and the consumption. Because consumption is there, it should be a closed system, but consumption is there because of some leakages. The steam is leaking from somewhere, the consumption is there, so that is why we have to continuously cope up with the water level. This is pretty much what we have. Thank you so much.